Boom. So a circular flower bed has a radius of 8 meters. What is its area? My party people, what are we looking for in this problem? What are we looking for here in this problem? Again, what's the goal? What do we want out of this question? Not what do we have? What do we want? There we go. Yeah, we want the area. Read the question sentence. If I start here, I'm reading the problem. The problem is that we have a circular flower bed and it has a radius of 8 meters. The question, the goal is here. Who, what, when, where, how many, which of the following? What is its area? Right there. So in this problem, what we want here is the area of a circle. And everybody, how many formulas are there for the area of the circle? Yeah, there's only one formula. And what is that formula going to be? The area is going to be equal to pi r squared. That's correct. Pi r squared. And so with that said, my party people, do we have everything we need in this problem to plug in? Do we have everything we need to get the answer? Yeah, I'll agree with you. That's correct. We do. We absolutely do. Tell me in the chat box, everybody, this R stands for what? The R stands for the radius. Correct. R stands for the radius. And so let me actually, whoever's watching the recording, I want to make sure you can see that clearly. My pen just slipped. There we go. So we plug the radius into here. So with that said, my party people, we have the radius of 8 meters. So let's go ahead and highlight that. Everybody, we are replacing the R with what again? Just want to hear you say it. Yeah, it's going to be 8. So we have pi times 8 squared. Question, are we replacing pi with 3.14? No, I don't, at least not yet. Yeah, sure, B and, just B doesn't have pi in it, but A, C, and D have pi. So I'm going to leave pi as pi. I'm going to leave it as pi. And if whatever this turns into is one of these, then hey, we're good. We are good. So everybody, help me out here. Calculate with me because I'm going to be super confident. I am super confident right now that when we do pi times 8 squared, we're going to end up getting 16 pi, right? Right? This is me as your coach. I'm forcing you to agree with me. I'm kidding. No, that's going to be incorrect. And so for anybody here who is adamantly believing that, yeah, we should be getting 16 pi, let me actually help you understand why that's not the case. It's actually a very common mistake. So let me not make you feel bad. It's a very common mistake for people to interpret squaring something as doubling it, but it's not the same. I got you. So let me just take a red highlighter and just do that to make sure you clearly see that it's wrong. And over here, let me just remind you that if we have 8 squared, my party people, remember that squared, or any exponent really, that tells you how many times you're multiplying this number by itself. So 8 squared means you're going to have 2 8s multiplied together. 8 times 8 twice. Again, 8 times itself, like that. My party people, what is 8 times 8? 64. That's correct. And that's why pi times 8 squared is going to turn into 64 pi. Because 8 times 8 is 64. So that makes pi r squared 64 pi, making C the correct answer. Just like that, my party people. And there we are. So question here. So when do we add and when do we multiply? So I've never, at this point in class, we haven't really added. I think you're wondering when do we, double or cut in half? And remember, that's going to be the interchanging the relationship between radius and diameter. So from radius to diameter, double it to get the diameter. To get back down to the radius from the diameter, cut it in half. That's that. Yeah, I got you, Lewis. No worries. I knew that's where your mind was. I got you. And then again, for circumference and area, 2 different formulas, and you have to interpret what you got from there. So At this point, I'm going to ask my party people, do we feel like we're ready to try to work under a timer, to try to practice these problems on our own to see if we can interpret what the goal is, what we have, the formula we need to use, and then following through on that math? Hey, I love that response. I love that response. Who was that? Who said that? Oh, Nikoi. No, but I want to give it a shot. I respect that all the way. So with that, let's go ahead and get it done here, my party people. So let me give you a timer here, and let's try the next one out. All right, coming up next here, let's take a look at this word problem where we begin with that question sentence first. And what it says is, what fraction of the original cookies remained in simplest terms? Okay, so this is another unique type of question here where what we want to do, and let me just show you again, what we want to do is we want to end up by writing a fraction. We want to write the fraction of the original cookies that remained. So here's what this is asking us to do, everyone. Just based off of these red highlights, everybody, what is the F word that we went ahead and highlighted? Go ahead and repeat that for me, whether it's out loud in the chat box. What is it that they're trying to have us write? They want us to end up here writing a fraction, okay? That's what they want. And what this fraction is going to represent is the fraction of the original cookies that remained. So here's how I'm going to write this. We are going to write it as the amount that remain out of the original amount. Just like that. We're going to go ahead again and write down what remains over the original amount. So to get that done, my party people, here's what we're going to do. We're going to read through the context. We're going to read through the story to get what the original amount was. And that's going to be right here. A party made 40 cookies for an event. There we are. Boom. So we know what that original amount is going to be. It's going to be 40. Now up next, it says by the end, 28 were consumed. Everyone, would I be correct in simply taking that 28 and smacking it right there in the numerator? Would that be the proper way to go about it? No, absolutely not. Because the 28 represents the amount that was consumed, not remains. That's the amount that was consumed or eaten by our party people here. So that's not what goes there. What's going to go there is we started with 40. We consumed 28. To get how many are left, everyone, 40 minus 28, how many remain? Yeah, that'll be 12 because we'll go up 2 from 28 to 30, then 10 more to get to 40. So 10 and 2, that's 12. Or you can subtract any traditional way that you would prefer. But again, 40 minus 28, that's going to be 12. So that's what we needed there. 12 remained. Now we're properly representing the fraction that we wanted. How many remain out of the original amount? 12 out of 40. And so the last thing that we need to do from here is simplify. Everyone, what number can we divide? The biggest number we can divide from both 12 and 40. Because I know they're both even. I know we can start with 2, but there's a bigger number, and that's going to be 4. Yeah, so let's go ahead, move this right up, give ourselves that space. We will divide by 4 on the top and the bottom, and we'll see that 12 divided by 4 leaves us with 3. 40 divided by 4 leaves us with 10. Therefore, our correct answer for this practice problem, everybody, is going to be answer choice B, 3/10.